Note down this problem. A point charge Q is placed at point O as shown in the figure. Is the potential difference VA minus VB. VA minus VB is the potential difference VA minus VB positive, negative or 0? If Q is A positive, B negative. A point charge Q is placed at point O as shown in the figure. Is the potential difference VA minus VB positive, negative or 0? If Q is positive or negative. Here it is, positive or negative. So I is there. Q is positive or negative, or when Q is positive and negative. So the figure is given. O, A and B. This is the given figure. A point charge Q is placed at O. Is the potential difference VA minus VB is positive, negative or 0? If Q is, the first case is positive and B is negative. Now let the distance of points. Now first we will see what is VA minus VB. We will write VA minus VB in terms of the distances of A and B from O. So let us, so through the equation VA minus VB we can say whether VA minus VB is positive or negative. So let us assume the distances as RA and RB. Let the distance of points A and B from charge Q be RA and RB respectively. RA and RB respectively. So now according to us, this is Q, O, we have A and B, and we have assumed this distance as RA and this distance is RB. So distance of A and B from OA is RA and RB. Let the distance of points A and B from charge Q be RA and RB respectively. Now what is VA minus VB? We can write VA minus VB. Sorry. Minus VB equal to 1 by 4 pi epsilon naught, or Q divided by 4 pi epsilon naught into, so VA is Q by 4 pi epsilon naught into 1 by RA. You can use the to find out VA and VB, you can use the equation. What we have learnt is potential due to a point charge. So I will write separately. Electric potential at point A. Potential at point A. VA. VA equal to Q divided by 4 pi epsilon naught into RA. So this is according to the equation which we have derived. Similarly, potential at B due to charge Q is given by potential at point B. VB equal to Q divided by 4 pi epsilon naught into RB. Now calculate VA minus VB. Equal to Q divided by 4 pi epsilon naught into 1 divided by RA minus 1 divided by RB. Now we need to know the sign of VA minus VB, because so in the figure it is clear that RA is less than RB, or RB is greater than RA. RA is less than RB. From the figure it is very clear that RA is less than RB, or 1 by RA is less than 1 by RB. Sorry, 1 by RA is greater than 1 by RB. One by RA is greater than 1 by RB. Now, therefore, one by RA minus 1 by RB is always positive. Is always positive. Is always positive because 1 by RA is greater than 1 by RB. So in this is always positive. Therefore, the sign of VA minus VB now depends upon Q. the sign of VA minus VB depends on the nature of charge Q. Nature of Q. So VA minus VB is positive when Q is greater than 0, and VA minus VB is negative when Q is less than 0. Finally, we can write the answer. VA minus VB. VA minus VB. VA minus VB is positive when Q is greater than 0. Similarly, VA minus VB is negative when Q is less than 0. VA minus VB is negative when Q is less than 0. Q is less than 0, VA minus VB is negative, and VA minus VB is positive when Q is greater than 0. So very simple. What you have to do is, you just write the equation for VA minus VB in terms of the distances and charge Q. So then you can easily find out the sign, positive or negative. So that is what our question. Next question is one more question. Name the physical quantity whose SI unit is joules per coulomb. Is it a scalar or a vector quantity? Joules per coulomb, that is work done per charge. That is the unit of electric potential, and we know it is a scalar quantity. Joules per coulomb is the SI unit of electric potential, and we know it is a scalar quantity. It's a scalar quantity.